What if the sun suddenly vanished during the day or the moon disappeared at night? Well, these aren't science fiction scenarios. They're real phenomena that happen right here in our solar system. Welcome to PhysicsAI, where we explore the incredible physics of our universe. Today, we're diving into one of nature's most spectacular shows, eclipses. And trust me, the physics behind them is absolutely mind-blowing. Let's start simple. Imagine you have a lamp and a ball. When light from the lamp hits the ball, it creates a shadow. That shadow is simply an area where light has been blocked. Now scale this up to cosmic proportions. We have our sun as the light source, and both Earth and Moon can act as the ball, casting shadows into space. These shadows have two parts, the umbra, which is the dark inner shadow, and the penumbra, the lighter outer shadow. An eclipse happens when the sun, Earth, and Moon line up in what astronomers call syzygy. But depending on the order of this alignment, we get two completely different types of eclipses. A solar eclipse occurs when the moon passes between the sun and Earth, casting its shadow on our planet. The moon's shadow races across Earth's surface at over 1,500 miles per hour, creating a path of totality. In a total solar eclipse, the moon completely covers the sun's bright disk, revealing the sun's beautiful corona, its outer atmosphere. In a partial eclipse, the moon only covers part of the sun, creating that famous crescent shape. And in an annular eclipse, the moon appears smaller than the sun, creating a spectacular ring of fire effect. This happens because the moon's orbit is elliptical, so sometimes it appears larger or smaller in our sky. Here's the incredible coincidence. The sun is about 400 times larger than the moon, but it's also about 400 times farther away. This means they appear almost exactly the same size in our sky, making total solar eclipses possible. Remember, never look directly at the sun during an eclipse without proper eclipse glasses. It can cause permanent eye damage. A lunar eclipse is the opposite scenario. Earth passes between the sun and moon, casting Earth's shadow on the lunar surface. Earth casts a much larger shadow than the moon, which is why lunar eclipses last much longer, sometimes over an hour. During a total lunar eclipse, the moon doesn't disappear completely. Instead, it turns a beautiful deep red color. This happens because Earth's atmosphere acts like a lens, bending red light around our planet and onto the moon's surface. Blue light gets scattered away by our atmosphere, but red light makes it through, giving the moon that eerie blood-red appearance. In a partial lunar eclipse, only part of the moon enters Earth's shadow. And in a penumbral eclipse, the moon only passes through Earth's outer shadow, causing just a subtle dimming. Unlike solar eclipses, lunar eclipses are visible from anywhere on Earth's night side simultaneously. Now you might wonder, if the moon orbits Earth every month, why don't we get eclipses every month? The answer lies in orbital mechanics. The moon's orbit is tilted about 5 degrees relative to Earth's orbit around the sun. This means most of the time the moon passes slightly above or below the Sun-Earth line, missing perfect alignment. Eclipses can only happen when the moon crosses Earth's orbital plane at points called nodes. These alignments create eclipse seasons that occur roughly every 6 months, when we can have multiple eclipses in a short period. On average, any given location on Earth sees a total solar eclipse only once every 375 years. Making them incredibly rare and special events. Eclipses are not just cosmic coincidences, they are windows into the precise and beautiful clockwork of our universe. They remind us that we live in a dynamic solar system where celestial mechanics create these incredible natural phenomena. If you love cosmic physics explained simply, subscribe to PhysicsAI for more mind-bending science videos. Until next time, keep looking up and questioning the incredible physics all around us.